You are on a rock of iron and silicate, spinning at 1,000 miles per hour, orbiting a giant star at 67,000 miles per hour. That star sits inside the Orion arm of the Milky Way, a spiraling disk of billions of stars, spanning 100,000 light-years across. If you traveled at the speed of light, it would take you 100,000 years just to cross from one edge to the other. The Milky Way itself is gravitationally bound to a neighborhood called the local group, which is just one tiny piece of the Laniakea supercluster, a sprawling web containing 100,000 individual galaxies. And Laniakea is one of millions of superclusters suspended within a void stretching 93 billion light-years from edge to edge. That is the observable universe. Through telescopes and mathematics, human beings have looked out into this vast dark and drawn a map. We have pinned down exactly where we live inside a structural hierarchy of unimaginable scale. We also figured out exactly how we connect to that map. Every atom in your body heavier than hydrogen, the calcium in your bones, the iron in your blood, the oxygen in your lungs, was cooked up inside the crushing pressures of a stellar furnace. Billions of years ago, stars ran out of fuel, collapsed, and exploded, scattering heavy elements across the void to form planets, and eventually you. We've built machines sensitive enough to prove these extreme cosmic mechanics. We've even captured direct images of supermassive black holes millions of light-years away, recording the glowing, superheated matter swirling around their edges. But here is the catch. Every star, every planet, every galaxy, every black hole, and every single piece of recycled stardust that makes up you and me, all of it combined accounts for exactly 5% of the universe. All of chemistry, all of physics, and everything we have ever observed applies to a tiny sliver of reality. We are completely blind to the remaining 95%. This diagram shows the rotation of a standard spiral galaxy. Based entirely on the mass of the visible starlight and gas we can measure, physics dictates how fast these outer stars should orbit the center. But when astronomers actually measure those outer stars, they are moving incredibly fast. They are moving so quickly that the visible gravity of the galaxy isn't strong enough to hold them. By all known laws of physics, they should fly off into the void, yet they stay securely in orbit. That means there is massive, invisible weight holding the galaxy together. We call this dark matter, and it makes up 27% of the universe. We know exactly where it is because we can calculate its gravity pulling on the stars. But it doesn't emit, reflect, or absorb any light at all. To human humanizing instruments, it is completely invisible. The structural integrity of every single galaxy in the universe relies entirely on a substance that physics cannot yet identify. And dark matter is the easier of the two mysteries to grasp. The other 68% of reality belongs to something we call dark energy. For a long time, the assumption was that the expansion of the universe following the Big Bang was gradually slowing down. But in 1998, astronomers measuring distant light made a truly startling discovery. The expansion isn't slowing, it is actively accelerating. Something is continuously pushing the very fabric of space apart, driving galaxies away from each other at faster and faster speeds. We call this unknown force dark energy, and we have virtually no idea how it works. The scale of what we don't know applies to time as well. The universe has been running for 13.8 billion years. Human beings have existed for roughly 300,000 years. Our entire history occupies a fraction of a percent of the cosmic timeline. Within that deep time, across billions of potentially habitable planets in the Milky Way alone, intelligent life has had ample opportunity to evolve and spread. Yet, as we constantly listen to the stars, we hear absolutely no signals, no massive structures, and no alien visitors. We are floating in a void that is expanding away from us at an accelerating rate, surrounded by invisible forces we can't measure, locked in a profound, unexplained silence. Eventually, the universe will exhaust its supply of hydrogen fuel. Trillions of years from now, the process of star formation will permanently cease. Existing stars will slowly burn out. What remains will be a graveyard of stellar remnants, cooling white dwarfs, incredibly dense neutron stars, and isolated black holes slowly evaporating in the dark. Finally, after a nearly incomprehensible amount of time, the cosmos will reach a state of maximum entropy. All remaining matter and structure will break down, leaving only a cold, dark, diffuse sea of scattered particles where nothing ever happens again. The universe operates on an immense, uncaring timeline, and it is quietly, steadily marching toward absolute nothingness. But that ultimate ending makes our current reality astonishing. In the midst of this cold, massive indifference, an incredibly rare sequence of events occurred on this exact planet. Against tremendous astronomical odds, ordinary, dead stellar waste arranged itself into a biological structure capable of forming thoughts, making tools, and asking questions. We built rockets to leave our atmosphere. We launched metal probes deep into interstellar space, attaching golden records stamped with the sounds of our world, just to see if anyone else in the dark might be listening. Human civilization may only account for a rounding error in the vastness of cosmic history. Our physical bodies may be confined to an insignificant speck in an ever-expanding void. But we are the stardust that woke up. We are the universe developing the capacity to look back and wonder about itself. And that makes our brief time in this 5% infinitely valuable.